Hi everyone, let's solve today's daily challenge, that is kth missing positive number. So in this question we are given an array of positive integers sorted in strictly increasing order and an integer k, and we need to return the kth positive integer that is missing from this array, right? So we are given this particular array here and we are given this k integer, right? So the array should be, okay, let's see the question. Okay, wait. Yep, so let's see. So here we are given this array, right? Okay, wait, this is too thick. Okay, wait. Okay, this is fine. Yep, so we are given this array here, right? Now see, what they're saying is we need to tell the fifth missing number. So basically the array should have been like 2, 3, 4, 5, 6 and so on, right? Now in this array you can see there are some missing integers from this particular range. So let's see what those missing integers are. First, 1 is not present, right? Then 2, 3, 4 is present, 5 is not present, then 1, 5 and 6 is not present, we have 7, then we have 8 and 9 and so on. So here you can see the fifth missing integer is 9, right, which is not present in this array. So we have to return this particular number, right? Similarly, if you see the second test case here, we are given this array, right? 1, 2, 3 and 4 is given to us, and see, it is in strictly increasing order, and from 1 to 4 all the numbers are present, and we need to find the second number, right? Second number which is not present. Now after this 1, 2, 3, 4, what number should have been there? So they are 5, 6, 7 and so on, right? We should be having these numbers. Then now we are saying the second number which is not present, so that is what? That is 6, right? So 6 is the second number that is missing from this array, so we will return 6 here. So I hope you understand the question. Now you can easily solve this question in O of n complexity, right? You can simply take an array, because the constraints, if you see, are also like up to 1000 only. So you can easily take an array with 1000 elements and you can try to search for the elements which are missing, and out of them you can easily return the ones that is asked to you, right? Now here in this question we are also given a follow-up, right? Can you solve this problem in less than O of n complexity, right? So we will be seeing that. Also before that, Newton School is organizing a Code Rush March edition, right? It is a contest, so you can go and register in this contest. I will share the link to the contest in the description box, so you can go here and you can simply register for this contest, right? Okay, now let's get back to the question. So here, yep, so we need to solve this question in O of log n time, right? So let's see how we can do that, right? So we have this particular array here, right? And one thing that you look here is that we need log n complexity, right? Log n complexity plus, if you see, this array given to us is sorted, right? It is in strictly increasing order, right? So if the array is in strictly increasing order and we are being told to do something in log n, so one thing that comes to our mind is binary search, right? Because binary search does the same also, right? What it does, it computes or it searches for an element in log of n time, right? So let's see how can we apply binary search here. Now in this question what we need to find is the missing number, the kth missing number, right? And this number can be from any like for example between 1 to 1000, it can be anything, right? You can say that. So let's see how binary search can be applied here. So one thing that you can see here is, if I take positions of these particular elements, right, and using these position, can I find how many elements are missing, right? Let's see how can we find that. So here you see this is 0th position, this is 1 position, right? So you can say that if it was a normal array, for example if it was 1, 2, 3, 4, if it was an array like this, right, then if I take the position, because the indexes start from 0, if I take index plus 1, right, so they would have become 1 for this 2, for this 3, for this 4. So that means if you subtract these quantities, right, that is the particular element minus the index plus 1, right, then you should have been getting 0, right. But here you can see but let's say one of the element went missing. Let's say it was 1 that went missing. So we will be starting from 2, like we are starting in this array with 2. So we will be getting 2 minus 1, that is 1 element is missing, right. Similarly, after 2, if 3 is present, right, then also the difference will remain 1, right. So I hope you are getting that we can use the indexes and those particular array elements to know how many elements are missing, right, from that particular index. Before all the elements that are present before that particular index, we can know how many elements are missing in them, right. So first thing to notice is this, we will be using this observation, right. Now let's see where we are going to apply binary search exactly, right. So we will be applying binary search on the indexes of this array, right. We are starting from 0 and we will be going till the length of the array, right. What is the length of the array? It is 1 2 3 4 5, right. So we will be going up to 4, that is n minus 1. So we will be doing binary search here. Now what we'll be trying to compute, right, how will we be doing binary search? So see, now if you want to find the kth missing number, right, now let's write the numbers missing for each and every index. So it is 1 here, right. For this index it is also 1, right. For 4 it is also 1, right. For 7, how many elements went missing? This position is what? This is 4th position, and 7 is 7. So 7 minus 3 we will do. We will get 3, right. So 3 elements before all 7 are missing, right. At 11, the index at 11 is 5, right. Index plus 1, that is 5. 11 minus 5 is 6. Now you want the 5th missing number, right. So where will you be getting the 5th missing number? You will be getting it somewhere here, right, between 3 to 6, because we know 3 numbers are missing before 7, and before 11 there are 6 numbers missing. So the 5th number you will be getting here, right. So after 7 you will be getting the 5th missing number, sorry, after 3. So in this particular range we will be getting. So this is what we will be using. So we will be iterating in our indexes according to this only, right. What we will check? We will check if our array, right, array of mid, right. First we will be calculating mid, right. We are checking whether we will be moving, right, left or right, what part of the array we will be rejecting and what part of the array we will be considering, right. We will check array of mid minus index plus 1, right. We will be checking this. Now if this quantity, right, if this is less than k, then we should move towards the right, right, if this is less than k. But if it is greater than k, then we should stop, right. We will not be moving towards the right, right. We will stop at that point, because this particular value we will be having, but as soon as this particular quantity exceeds k, right, then we will be stopping. So then we will be getting this range here, right, and we will be, now let's see how we will be calculating an answer using this range. Now if you see this range, we have 3 here, right. We are saying that after 7 there are 3 elements that are missing, right. So 7, right. Now if I try to add, I will try to find a quantity, right, that I can add to 7 and know which number is missing. So here you can see that it is the 5th position. 5th is the target position, and we are already at 3, right. So what do I have to add? I have to add 5 minus 3 to 7, right. So what will I get? 7 plus 2, that is 9, right, and 9 was our missing 5th number in this array, right, and you can easily get an answer using this, right. So what is this basically, right? If you try to compute this, if you try to compute this, how will you be calculating 7 plus 2, right? So let's see. So what we'll be doing is, we will be taking low, array of low, right? And we will be doing what? We will be taking, so we will be adding something to this array of low. Now what is that we will be adding? So we will be adding k minus array of low. Okay, wait, let me rub things here a little bit. Right, so what we'll be adding? We will be adding array of low, right, minus low. We will be adding this quantity, right? If you simplify this quantity, what you will be getting? So if you compute this particular, this and this term will get cancelled, and this minus and minus will turn into plus. So what you will be getting? You will be getting k plus low, right? That is whatever your low index is plus the target, right? So see here what your low index is. Your low index is this, right? So what is this index? This is 4, right? So if you add 4 to 5, you get 9, right? So that is our answer. So I hope the intuition of and the approach of the problem is clear to you. What we'll be doing? We will be doing binary search. Where are we doing binary search? We discussed that if you take a particular array element, right? So let's take array of mid, and if you subtract that particular index plus 1 from it, you can get the number of missing elements, right? So we are doing binary search on the number of missing elements, and then we are trying to find a range, right? We are trying to find a low where which is just less than this particular value, just less than high, right? And what we are doing is we are simply using this particular index to calculate our missing number, because here what we will be getting? We will be getting a range, and our answer will be lying in this particular range only. So what we will be doing? We will simply take this particular index and we will simply add the target here, that is k plus low. As we saw here, we can, like, we were computing this quantity, right? But if you simplify this, you will be getting low plus k, and that is the answer, right? So let's see in code also. So the approach is a bit tricky, but coding the approach is easy, right? So here what we are doing is, we are taking low and we are taking high, right? These are the array indexes, right? The first index of the array and the last index of the array. Then what we are doing? We are calculating a mid, right? We are doing binary search in this particular loop, and we are calculating a mid. How are we rejecting one half or the other half? What are we calculating? First we are calculating this particular quantity, right? So what we are saying? We are saying array of mid minus mid plus 1, that particular index plus 1. If this is less than k, move towards right. Otherwise, move towards left, right? And stop if this becomes greater than k, right? And then what you have to do? We saw that once you get this particular low quantity, once you are at this particular low quantity after this loop ends, if you just add k to it, you can get an answer. So that is all you have to do. So I hope the question and the problem statements are clear to you, and how to use binary search is also clear to you.